As an application developer, implementing a robust and scalable architecture is crucial to the success of your software. One modern architectural pattern that addresses these concerns is the Backend for Frontend or BFF design. A BFF architecture provides tailored APIs to serve specific front-end clients. By designing your backend this way using Spring Boot, a popular Java framework, you gain many benefits. What is the BFF, Backend for Frontend, architecture? The BFF, Backend for Frontend, architecture pattern provides an interface between the front-end and back-end components of an application. The BFF sits between the front-end, client-side, and traditional back-end, server-side, applications. It acts as an intermediary, handling requests from the front-end and retrieving data from the back-end. The BFF then crafts responses specifically tailored for the needs of the front end. Some of the main benefits of the BFF architecture are decoupling the front end and back end. The BFF isolates the front end from changes in the back end API. This means front end developers can iterate quickly without waiting for back end changes. Optimized API. The BFF can provide an API optimized for the needs of the front end. It aggregates data from the back end and reshapes it into the format most convenient for the front end. Added security. The BFF acts as an additional layer of abstraction and can implement extra security measures to protect the back end API. Flexibility. The BFF architecture allows for multiple BFFs to use the same backend API. This means different front ends can be built on top of the same backend services. Scalability. BFFs can be scaled independently from backend services as needed to handle traffic from the front end application. By implementing a BFF architecture, the coupling between the front end and back end is reduced. This provides more flexibility, optimization, and scalability for the overall application. For any front-end developer, understanding the BFF pattern is becoming increasingly important. How to implement BFF in Spring Boot? To implement a BFF architecture in Spring Boot, follow these steps. First, create a Spring Boot application with the web dependency. This will enable Spring MVC, allowing you to build RESTful web services. Next, define request mappings for your BFF API. For example, Java at REST controller public class product controller at get mapping and quote products and quote winking face public list and lieutenant product and GT get products. This will expose an endpoint at products to fetch products. Then, create request mappings that proxy to your backend services. For example, Java at REST controller public class review controller at get mapping and quote products producted reviews and quote winking face public list and lieutenant review and GT get reviews at path variable int producted return REST template get for object and quote http://reviews service products and quote producted and quote reviews and quote list class this proxies the products producted reviews request to the reviews service. Finally, you can add caching, security, and other cross-cutting concerns to your BFF. For caching, use the @cacheable annotation. For security, use Spring Security. Your BFF can handle these non-functional requirements before proxying requests to microservices. By following these steps, you can implement a robust and useful BFF in Spring Boot. The BFF pattern is a powerful way to provide a single entry point for your clients and handle cross-cutting concerns in a microservice architecture. The pros of a BFF architecture with Spring Boot. A BFF, Backend for Frontend, architecture utilizing Spring Boot has several benefits for developers. Increased productivity with a BFF. The backend is tailored to the needs of a specific front end. This allows developers to be highly productive as they can focus on building API endpoints that directly match front-end requirements. There is no need to build generic endpoints that suit multiple front ends. Focus on UX. The BFF layer can be optimized for the best user experience on a particular front end. For example, the data can be tailored to match the UI, and endpoints can directly correspond to front-end actions. This allows the front end to operate smoothly, without extra processing logic. Scalability. The BFF pattern scales well as more front ends are added. Each front end can have its own dedicated BFF, and the back-end services that provide data can remain unchanged. This allows the overall system architecture to grow in a flexible manner. Independent deployments. The BFF and front end can be deployed independently of the back-end services. This means new features can be shipped to users quickly without having to update the underlying back-end systems. The BFF can be updated to call new endpoints in the back-end services when they become available. Less risk. Making changes to a BFF has less risk than changing a generic back-end API. If there are issues with the BFF, only one front end will be affected. The underlying back-end services remain stable and unaffected. This approach reduces the risk of making changes and allows developers to iterate quickly. In summary, a BFF architecture in Spring Boot leads to increased productivity, better UX, scalability, independent deployments, and less risk. By tailoring the backend to a specific front end, developers can build optimal solutions for end users. How to connect multiple BFFs in Spring Boot. To connect multiple BFF services in Spring Boot, there are a few approaches you can take. Using Feign clients. Feign is a declarative web service client that makes writing web service clients easier. To use Feign, you need to create an interface and annotate it with @Feign client. In the interface, define methods to call other BFF services. For example, to call an unquote accounts unquote service, you'd have Java @Feign client, name equals unquote accounts unquote URL equals and quote http://accounts.example.com and quote winking face. Public interface accounts client @getMapping and quote accounts id and quote winking face. Account get account @path variable long id then you can inject an instance of accounts client into your controller or service and call getAccount. Feign will handle making the HTTP request and decoding the response. Using REST template. REST template is a simple REST client in the Spring framework. You can use it to make requests to other BFF services like this. Java REST template equals new REST template account equals REST template. Get for object, and quote. http://accounts.example.com/accounts/id, and quote. Account. Class. id. REST template works but isn't as robust or declarative as Fein. I would recommend using Fein for calling other internal services. Sharing API definitions to ensure multiple BFF services have a consistent API. You can share API definitions between them. Options for this include using Open API, Swagger specifications. Each service exposes an Open API spec, and other services consume it. Sharing DTOs, data transfer objects, and controllers between services. Extracting a shared API library that contains DTOs, controllers, and more. Each BFF includes this library. By sharing API definitions, you get a consistent experience for clients no matter which BFF service they call into. You also reduce duplication of code across services. Overall, connecting BFF services through API sharing and tools like Fein helps create a cohesive microservices architecture in Spring Boot. Best practices for your Spring Boot BFF when building a Spring Boot BFF. There are several best practices to keep in mind. Following these will help ensure a clean architecture and seamless user experience. Keep controllers lean. Controllers should delegate to services and avoid business logic. They are responsible for translating requests to services and returning responses to clients. Keep controllers focused and avoid and quote. Fat and quote. Controllers. Build reusable services. Services should handle the bulk of business logic and validation. Build services to be reusable across controllers and applications. This reduces duplication and ensures consistency. Services should follow the single responsibility principle, having one clearly defined purpose. Use contracts for requests and responses. Define contracts, or interfaces, for requests and responses to decouple clients and services. This allows them to evolve independently. Contracts can be defined as Java interfaces or by using schema definition languages like JSON Schema or Apache Avro. Cache repeated calls. Add a caching layer to improve performance of repeated calls to services. You can cache at multiple levels: controller, service, or repository. Use a cache like eCache or Redis and cache based on request parameters. Bust the cache when data changes. Monitor your application. Monitor metrics like request counts, response times, error rates, and cache hits to get visibility into your BFF's performance and health. Use a tool like Prometheus to collect metrics and Grafana to visualize them. Set up alerts to notify you of issues. Test thoroughly. Write unit, integration, and contract tests to ensure your BFF is functioning as expected. Unit test services in isolation. Write contract tests to verify requests and responses match the defined schema. Integration tests validate the end-to-end flow through controllers and services. Aim for a minimum of 70% code coverage. Following these best practices will set you up for success with your Spring Boot BFF architecture. Let me know if you have any other questions. Conclusion: as you have seen, implementing a BFF architecture in Spring Boot provides many benefits for your application and its users. By decoupling the front end and back end into separate, specialized services focused on their own domains, you gain increased flexibility, scalability, and velocity. Your front-end team can iterate quickly to improve the user experience without being slowed down by back-end changes. Your back-end services can be scaled independently as needed to handle increased traffic. Overall, a BFF architecture leads to a cleaner, more modular codebase that is easier to maintain and evolve over time. The additional upfront investment in architecture and infrastructure pays off through faster development cycles, improved resilience, and a better experience for your end users. The move to a BFF architecture in Spring Boot is well worth the effort.